We have discussed the advantage and disadvantage of the P controller, PI controller and PID controller. So far we can decide that out of the control of variables, pressure, temperature, composition, flow, and what else, pressure level, which controller should be most suitable. Okay, so we know that how the controller gives output, how the controller output is related to the relation to the error coming to the controller, right? Now the question arises that, okay, now how a control loop works, and whatever features we have discussed for the theory of controllers. I mean, for P controller we have discussed that there is an offset, so we will also learn how to calculate offset. We have discussed that for for PI controllers there will be oscillations. We have discussed that for PID controller D action won't affect anything. For PI controller the order is going to increase. So we are going to prove all these things mathematically. But before proving all these things, before calculating offset, order of all those things, we have to understand a lot of terms related to process control. The first thing is the block diagrams. Fine. Before this, आपने देखा होगा कि एक process control का जो मैं आपको representation दिखाता हूँ. Normally, what I do, that I take the example of a liquid level system. That liquid level system is controlled with the help of a controller. There is a valve, manipulated variable, input variable, output variable, सारी चीजें होती हैं, है ना? Okay, so normally when we discuss control, when we have to calculate all these things, we have to discuss the response in the presence of controller. Normally we don't make the physical diagram, a real control system. What we are going to do, instead of making the real physical system, we are going to make a representation of that, and that is called block diagrams. Write down. Block diagrams are representations of the physical control system. What is the meaning of physical control system? So block diagram, as in block diagram is just a circuit kind of representation. है ना भाई, देखो ऑब्वियसली चीज है, आप घर में देख रहे हो वायरिंग है, देयर आर स्विचेस, है ना, देयर आर वायर्स, देयर आर एमसीबी बोर्ड्स, देयर आर स्टेबलाइजर्स, वेरियस थिंग्स आर, देयर आर द electricity equipments also. That is the physical system. But when you have to make some representation of these electrical appliances, these electrical system, the electrical circuit, then you try to make the things in the form of a block diagrams. That is the same way. Why, instead of making the real physical control system, I mean, instead of making a liquid level tank, instead of making a valve, right, instead of making the disturbance, showing the output variable, showing the controller, the set point, what I'm going to do, that I will be representing that in the form of a block diagram. So they are representations of the physical control system. Fine. Now what are block diagrams? In PDC and feedback control. In feedback control. So whatever block diagram I will be drawing here, that will be for feedback control only. So in feedback control, the block diagram is made as, see, you know that I told you that each and every system, each and every unit of a control system has some transfer function. Suppose the process has a transfer function GP, the controller has a transfer function GC, the valve has a transfer function GV. Each and every element has some transfer function. The final control element, which is the valve, sometimes we write GF. Okay, so each and every element, each and every component of the control system has some transfer function. Sometimes you will feel कि sir इसका तो transfer function ही नहीं है, आपने कहा था कि हर चीज का transfer function होता है. Then in that case you have to assume that the transfer function of that particular system is equal to 1. The transfer function actually relates the input to the output. If input is equal to output, we can say that the transfer function of that component is equal to 1. So how we make this block diagram for this representation of a system in PDC for feedback control system? We'll make the block diagram like that. Please note, this is not the actual process. This is not the liquid going. This is just a representation. Okay. This is the set point, YSP. Please note that in the block diagram, all the variables, all the representations are in the S domain. So this should be written as YSP bar S. Right? ध्यान रहे ब्लॉक डायग्राम में जो भी चीजें, जो भी वेरिएबल मैं लिखता हूं, all those variables are in S domain. And why these block diagrams are there? They are actually representing the physical process, right? And they are showing that what is the input, what is the output. Okay, so YSP bar S denotes the set point. Then there will be a block, right? This block represent, see, everything here is a function of S, GSPS, which means the set point ka transfer function, set point transfer function. Okay, now this goes to a symbol. This symbol in control theory is called summation point, or you can say comparator. Of course, when we make the real system, we don't show the comparator. We assume that the comparator is there inside the controller. But here I'm going to show the comparator separately. So the output of this system goes to the controller, and there is a positive sign here. We also call it comparator. We also call it summation point. Sometimes we'll call it comparator, right? Or why summation point? Because it is acting as the junction of two types of signal. From here, what is coming is called the measured value, right? Measured value. Measured value of what? Measured value of the controlled variable which we are controlling, right? And this value has a negative sign here. Fine. Due to this reason, this feedback which is going here, this is the feedback which is coming from the control variable. Let me make that also. Suppose I am trying to control this variable. What is Y? Y means the output variable. I am trying to control this. You know that in feedback control, what is the idea? The idea is whatever I want to control, I am going to measure that first. जो भी मुझे कंट्रोल करना है पहले मैं उसको मेजर करूंगा, right? I'm going to measure that first and then I will send the feedback to the controller. आपको मैंने कई सारे एग्जांपल दिए थे कि first it will be measured. So how it will be measured? मुझे measure करना है, I will measure it. This is another line which shows that that thing is getting measured, that variable is getting measured, and then it is sent. And how it is measured? Always it is measured with the help of some measuring element. Of course, the measuring element will be having some transfer function. Let's call it GMS. है ना? बिना measuring element के आप transfer function, बिना measuring element के you can't measure the control variable. This is the control variable or output variable. I'm measuring this with the help of a measuring element. Now the measuring element is giving some output that should be called as measured value, right? That measured value, we can call it MV in short, with the negative sign is sent to the comparator. Due to this negative sign, this kind of feedback control is also referred to as negative feedback. Negative feedback. Okay. Negative feedback control strategy. तो अगर आपसे कोई ये पूछ दे कि ये जो आप जितनी भी स्ट्रेटेजी पढ़ते हो, दिस इज फीडबैक. इनिशियली वी विल डिस्कस मोस्ट ऑफ द केसेस फीडबैक कंट्रोल. सो उसमें कौन सी फीडबैक स्ट्रेटेजी? दिस इज नेगेटिव फीडबैक. पॉजिटिव फीडबैक भी होता है. वी डोंट डिस्कस पॉजिटिव फीडबैक हियर. Okay, so this comparator is going to compare this set point which is coming from the operator and the measured value with the algebraic sign. It is going to be added. That is why it is called summation point. And of course, when this is added, this is having negative signs. So what will be released? What goes into the controller is epsilon bar S. You know that the controller works on error. So into the controller, what goes is error. It is having the transfer function GCS. Now, what kind of controller it can be? It can be a P controller, PI controller, PID controller. Can be anything. Now, you see, now you compare this with the actual process. This is not the physical process here. The output of the controller goes to which component? The output of the controller is the decision, the controller output. We have discussed that the output of the controller is the controller output. Okay. And the controller output goes to which part? It goes to the valve. Valve is also sometimes called as final control element because it is someone who is doing the things, right? So final control element, right? So ये कुछ ऐसी चीज है जो रियल में है ना कुछ काम करे. So this is called final control element. They are also called actuators. They are also called actuators, or it can be, most of the cases, it can be valve. So we can write this transfer function as GF, GV, anything. So GF of a function of S. Everything is everything is a function of S. We are working in the Laplace domain. Now, when the valve changes, it is going to affect what? It is going to affect Y, right? It is going to affect Y. Okay, so this is affecting Y. But the problem is, along with this manipulated variable, this is the manipulated variable, fine. Along with the manipulated variable, the disturbance is also changing the output. I told you now what is the meaning of input variable. Input variable is that variable which has the capacity, which has the tendency to change the output variable. ठीक है, अब output variable को कौन-कौन change कर सकता है? If you take the example of liquid level system, the output variable, which is the liquid level, can be changed either by changing the valve position, which is the manipulated variable. So it is changing the output variable, but we also know that the output variable means the liquid level height can also be changed due to the inlet flow rate, and that inlet flow rate is the disturbance. So the disturbance transfer function is GDS, and it means this is D bar, or we can write capital D. Let's talk about in capital letters. We can write here D bar S. Okay, both with a positive sign. This makes the loop complete. Alright, this makes the loop complete. Okay, fine. This makes the complete loop of a negative feedback control loop. Okay, this is called a negative feedback control, है ना? And this kind of loop, because ये loop है ना? This is a kind of loop, okay? And okay, this is called negative feedback control loop. Of course, I have discussed the most simplest kind of loop here. Simplest है, सबसे simplest है. There can be, if you see the real control system, there are various strategies and the loop can be very much complex. Okay, right? So write down that this is negative feedback control loop. Okay. Now you can compare this control block diagram with the real physical system, and the most simplest one, I told you that whenever you want to understand the things, the most simplest control system is the liquid level control system. Now in this case, okay, I missed something. Okay, I'm sorry, I missed one. This thing, final control element. Now there will be, I missed this one. What is the output of final control element? It is the manipulated variable. Output of final control element is manipulated variable. Okay, so this is GPS, correct? This is GPS, the process transfer function, right? And the process transfer function, this is the output variable, and this output variable is can be changed by this manipulated variable as well as due to the disturbance. Now in this case, this path which is between error to this output, this path. So if we are talking about this, in this case, this path is called as forward path, right? This red thing, the red line is called forward path. Please note that in this forward path, the GD or D is not included. This is called forward path, while this one, which includes the measuring element only, and this is called feedback path, or that is called feed. The terminology is again important. This is called feedback path, forward path and feedback path. Note kar lijiye. Right. This is how a block diagram, a basic block diagram in control system is made. See, why block diagrams are important? Because whenever there will be a problem in process control, a numerical problem for calculating offset, for calculating stability, for calculating the response, there will be definitely, most of the times, there is a block diagram. Block diagram is always there, right? Most of the times there is a block diagram. So unless you know how to understand the block diagram, how to reduce the block diagram in the form of an equation, we can't solve majority of the process control problems. In dynamics, there is no block diagram. Dynamics में देखो, dynamics में there are transfer functions. Actually, dynamics में देखो आपने किया क्या? In dynamics, you have discussed this component separately. You have discussed this component separately. और अगर मैं आपको और डायनेमिक्स पढ़ाता तो हम वॉल्व की डायनेमिक्स भी पढ़ते. वी हैव डिस्कस दिस कंपोनेंट सेपरेटली, दिस कंपोनेंट सेपरेटली. सो एक्चुअली इन प्रोसेस डायनेमिक्स वी डिस्कस द डायनेमिक्स ऑफ इंडिविजुअल कंपोनेंट्स ऑफ दिस कंट्रोल सिस्टम सेपरेटली. एंड व्हेन वी टॉक अबाउट कंट्रोल, फिर मुझे पूरे लूप की बात करनी है. नाउ वी मस्ट नो दैट व्हाट आर द वेरियस कंपोनेंट्स एसोसिएटेड विद दिस लूप. दिस इज द स्टैंडर्ड लूप, राइट? दिस इज द स्टैंडर्ड लूप. ओके, नाउ of course, in some cases, I'm not saying that always all these components will be present, right? Suppose the question says there are certain points, please write down regarding this block diagram. Suppose the question says that a particular component, question says that a particular component has fast dynamics. What is the meaning of fast dynamics? Do you remember that system, the pure gain element? A particular component has fast dynamics, very fast dynamics. There is no value. Fast or very fast means the nature of input and output is almost same. It means we can say that fast dynamics, if not given, we can say that then the transfer function is called transfer function of that element or of that component is equal to 1. Transfer function of that component is equal to 1. तो अगर मान लो आपको ऐसा ब्लॉक डायग्राम दिया, ये मैंने अभी लिखवा दिया, ये कई बार ये वर्ड यूज होता है एग्जाम में, that the measuring element can be considered to have very fast dynamics. The final control element can be considered to have very fast dynamics, right? So in that case, even the process can be considered to have very fast dynamics. Disturbance can be considered to have very fast dynamics. So in that case, when the question says very fast dynamics, मतलब input और output में time नहीं लग रहा. The moment you are giving input, you are getting output, and even the nature is same. There is no lag, right? I mean, it is not taking time. आपने input ऐसा दिया, output भी आपको ऐसा मिल रहा है. So the transfer function is equal to 1 in that case. Also, sometimes we use these words. What I'm trying to do, I'm trying to make you familiar with this block diagram. Of course, this is not only one block diagram in process control. It totally depends upon the real control system. You can think of that I'm making this block diagram by imagining that liquid level control system in my head. Okay, then only I'm making this diagram. Fine. तो जरूरी नहीं कि ब्लॉक डायग्राम ऐसा दिखेगा. हो सकता है कि इसमें से कई सारी चीजें ना हो, बहुत सिंपल सा ब्लॉक डायग्राम हो. इट इज ऑल्सो पॉसिबल इट कैन बिकम अ वेरी कॉम्प्लेक्स काइंड ऑफ ब्लॉक डायग्राम. टोटली डिपेंड्स अपॉन द रियल फिजिकल सिस्टम. बट व्हेन आई टॉक अबाउट अ फीडबैक कंट्रोल लूप, वी नॉर्मली डिस्कस दिस डायग्राम ओनली ना, बिकॉज बेसिक यही है. और आपको मैं एक और बात बता दूं कि देखो, इन गेट एग्जाम इफ देयर इज अ क्वेश्चन ऑन ब्लॉक डायग्राम, it is mostly this type of question. In fact, many times it is simplified, many components are not present there. Okay, one more point. I was talking about, so this was fast dynamics. Any element is having fast dynamics. Yes, sometimes we use this word unity feedback system. Unity feedback system. You know that this loop is called feedback loop. If the question says that we have a unity feedback system, then GM is equal to 1. Right? GM is equal to 1. These are some thumb rules that you have to follow during the exam. Fine. Okay. Also, sometimes it is possible that you will be having a block diagram where there will be no GSP. Right? Of course, there will be controller, but there will be no GM, there will be no GF, there will be no GD. Right? So there are various simplifications of these block diagram. Now I told you about the forward path and I told you about the backward path. Okay, we'll come to this reduction of the block diagram. But before that, let me tell you one more thing, that if you see, there are two books in process control which is mostly followed in semesters. One is process control by Kafner, and the second one is process control by George Stephanopoulos. Okay, so we preferred, even in semesters we used to have this Kafner, but I personally prefer Stephanopoulos, and I like that book. That is well arranged according to me. Okay, if you see the two books, both are good. The two books follow, different notation for this block diagram. In GATE exam, this notation is followed, so not a problem. In the Kufner, if you see, in Kufner, this summation point and the disturbance, they are shown before the process here, right? While in Stephanopoulos, they are shown here. And many standard books, this practice is followed, that the summation point, the disturbance is shown after the process. It's all about the convention, right? But I feel this one is more accurate, this one is more correct, more close to the process actually. Therefore, आपको यही करना है, आपको जो disturbance है, जो आपका जो ये आपका summation point है, you have to show this summation point after the process, ठीक है? So suppose if you are reading something from the Kufner, if you are reading, then don't worry about that कि उसमें ऐसा क्यों ले लिया, right? Now there are block diagram reduction rules, okay? And how to reduce a block diagram, how to write the transfer function of all this closed loop system. Okay, sometimes see, when we have this kind of block diagram, you can see that this is the feedback path, right? So a loop with the feedback path closed, feedback path closed क्यों हुआ? It is going into this. This kind of loop is called closed loop. But if there is no feedback, suppose ये यहाँ से जाके निकल गया, there is no one to give this information here. Suppose I cut this loop from here, I cut this from here, right? Suppose I take a scissor and cut this. In that case, there is no feedback. Now that kind of block diagram is called open loop, right? Open loop block diagram. Fine. So अगर feedback path है, if there is the feedback path which is giving the feedback to the comparator, then the loop is called closed loop. If there is no feedback path going to the comparator, then the loop is called open loop, right? तो अभी के लिए इसको बना लो. So you can write down after this that feedback path present. ऐसा नहीं कि आप इसको काट के फिर बोलो कि सर feedback path तो है, मतलब उसका कोई मतलब नहीं है ना. It's not going anywhere. So if feedback path is present, feedback path is present, then it is called closed loop. It is called closed loop, है ना? And if feedback path is absent, if feedback path is not there or feedback is not there, okay, then it's called open loop. Then it is called open loop. Okay. Fine. Right. Now there comes that sir ये block diagram हम क्यों पढ़ रहे हैं? देखो कोई भी process है, when it is going to be controlled with the controller, we will analyze that process not by making the real physical system but by making the block diagrams. Now you must know that this y, right? This y is your output variable. You must know how to relate this y with your disturbance. Okay, let me write these names. This ds is called disturbance, or in control language it is called load variable. Disturbance or load, right? What is GD? GD is disturbance transfer function. GD is disturbance transfer function, process transfer function, final control element transfer function, GP set point transfer function, right? What else? This is the set point, as I told you, set point and set point transfer function. Fine. This is the comparator. You must know the names, all these things. Now the question arises कि sir इसको reduce कैसे करना है? And let me tell you one more thing. This subject is also studied, also discussed in the curriculum of electrical or electronics engineering also. Fine. Now they also have block diagram reduction, but their block diagram reduction and your block diagram reduction, the level is very much different. They have to use a number of shortcuts for reducing the block diagrams. बहुत सारे shortcuts होते हैं. Now many of students I have seen कि वो कहीं से इलेक्ट्रिकल इलेक्ट्रॉनिक्स का लेक्चर देख लेते हैं या गेट के क्वेश्चंस उठा लाते हैं या टेस्ट सीरीज में भी ऐसे क्वेश्चन उठा लाते हैं कि सर ये क्या है, इसको कैसे करेंगे. हमें सारे कंट्रोल पढ़ने का ये मकसद नहीं है कि बस हम ब्लॉक डायग्राम ही सॉल्व करते रह जाए ना. ऐसा नहीं कि सर ये ब्लॉक डायग्राम सॉल्व कर दो, वो ब्लॉक डायग्राम सॉल्व कर दो. एवरीथिंग कैन बी सॉल्व, बट इट विल टेक टाइम. And of course, there are shortcuts for solving the block diagram, but that is not required for attempting the chemical process control part, right? So do not learn any formula, क्योंकि देखो आप learn तो कर लोगे but आधा अधूरा करोगे, you will not be able to apply it correctly and then you are going to make mistake. So no shortcuts required for solving a block diagram problem, because in chemical engineering, even if you are getting a problem on block diagram, most probably it will not only be focused on solving the block diagram but finding something else from that. तो आपको ब्लॉक डायग्राम दिया होगा, उसको सॉल्व करके कुछ और फाइंड करना होगा. तो ऐसा नहीं होगा कि सारी कॉम्प्लेक्सिटी ब्लॉक डायग्राम में ही डाल देंगे, है ना. सो डोंट थिंक, हम लोग प्रैक्टिस कर लेंगे, हम लोग कुछ ब्लॉक डायग्राम की प्रैक्टिस कर लेंगे, बट देयर आर सम फंडामेंटल रूल्स. Whenever you solve a block diagram, there are some fundamental rules. What are those rules? Write down. Fundamental rules. Fundamentals. Rules for solving block diagram. For solving block diagrams. Okay. Fundamental rules for solving block diagram. See, first of all, I'm calling these the block as components, or sometimes I will call them block, right? And these as summation points. ठीक है? Summation point, block, 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 block. ठीक है? So first rule, if these are not standard, आपसे कोई पूछने वाला नहीं कि what are the rules for solving a block diagram. These rules I have made according to my own theories, according to my own ways of explaining the things, है ना. तो ऐसा नहीं कि आपको बुक्स में लिखी मिल जाएंगी, ये बस समझने के लिए और मेरे समझाने के लिए है. इफ देर इज नो, सॉरी आई स्टार्टेड राइटिंग नो. देखो, मैं कोई चीज आपको समझा रहा हूं, दैट इज माई वे, है ना. बट गेट अथॉरिटीज, गेट एग्जामिनर, दे डोंट नो कि मैंने क्या पढ़ा है ना. हाउ आई कैन यूज एनी एनालॉजी टू एक्सप्लेन द कॉन्सेप्ट्स. I want you to understand the things, okay? But अब मैं मान लो आपको कोई एग्जाम्पल समझा रहा हूँ. सपोज आई एक्सप्लेन द PID, I think eye action. I explained eye action with the help of a girl in your life. I explained that how her behavior and eye action behavior is quite similar. That was my way of explaining. But इसका ये मतलब नहीं है कि मैं आपको टेस्ट सीरीज में या फिर असाइनमेंट में क्वेश्चन दे दूं और वहां ये एनालॉजी यूज करके आई विल फ्रेम अ क्वेश्चन, है ना. बिकॉज गेट में ऐसी प्रॉब्लम्स नहीं आने वाले. मैंने कई बार देखा है दैट मेनी पीपल फ्रेम क्वेश्चंस बेस्ड ऑन देयर ओन वे ऑफ टीचिंग, विच इज नॉट स्टैंडर्ड. ये आई एक्शन का गर्लफ्रेंड से कंपैरिजन, दिस इज जस्ट फॉर यू टू अंडरस्टैंड, मे बी फॉर यू टू एंजॉय द सब्जेक्ट अ लिटिल बिट, है ना. बिकॉज इट्स डिफिकल्ट for you to enjoy this much of mathematical subject. तो मैं कोशिश करता हूँ कि PDC में, है ना, I try to relate the things with the real life feelings. Okay, but the thing is मैं इस पर क्वेश्चन नहीं दे सकता आपको. मैं क्वेश्चन बना दूँ इस पर तो फिर कैसे सॉल्व करोगे? आप कर लोगे, जिसने मुझसे पढ़ा, दूसरा बंदा कैसे करेगा? This happens with a lot of students. मेरे पढ़ाए हुए स्टूडेंट्स कई बार कहीं से क्वेश्चन उठा के ले जाएंगे कि सर ये ऐसे देखो, ऐसे लिखा हुआ है. Now that person has made that particular question according to his own way of explaining the things. वो गेट में नहीं पूछेगा, तो आप उसकी टेंशन मत लिया करो, राइट. आई वाज, बिकॉज मैं स्टूडेंट, मुझे क्वेश्चन भेज देते कि सर देखो ये क्वेश्चन क्या मुझसे नहीं हो रहा, आप अपना कॉन्फिडेंस वहां पे डाउन कर लेते हो. उस बंदे ने क्वेश्चन बना दिया, ये भी नहीं सोचा कि ये क्वेश्चन, ऐसा क्वेश्चन गेट में नहीं आता यार, है ना. I take various example to explain the things. I can't ask you questions based on those examples only. तो पूछूंगा तो मैं वही जैसा गेट में क्वेश्चन आता. हाँ, I can take anything, any example. That's my way of explaining. वो आपको पसंद आए ना, वो आपकी चीज है ना, नहीं भी पसंद आ सकती, दैट इज माई वे ऑफ एक्सप्लेनिंग द थिंग्स. बट उस पर क्वेश्चन नहीं पूछे जाएंगे. क्वेश्चन तो नहीं पे पूछे जाएंगे जैसे स्टैंडर्ड क्वेश्चन आते हैं. क्वेश्चन में जो वर्ड्स यूज होने चाहिए, जो एग्जाम्पल्स यूज होने चाहिए, द वेज ऑफ एक्सप्लेनिंग द क्वेश्चन, दैट मस्ट बी स्टैंडर्ड. सो डोंट ऑलवेज पैनिक, है ना. ऐसा नहीं कि आप ही में कमी है, ऐसा नहीं है. हो सकता है सामने वाले में कमी है. डोंट वरी. If you are not able to solve a problem that came to you somehow, कहीं से सर्कुलेट होते होते ही आपके सर्कल में आप तक आ गई, you were not able to solve the problem, it's not always your fault. You are totally correct at your place. हो सकता है कि उसको बनाने वाले ने उस पे ध्यान नहीं दिया, कैलकुलेशन मिस्टेक, आउट ऑफ सिलेबस, राइट, incomplete information, use of such words, those words which are not standard kind of words. तो क्यों सॉल्व करोगे आप? क्यों अपने माथा पच्ची करनी वहां पे? क्यों अपना दिमाग खराब करना? छोड़ दो ऐसी चीजों को, है ना? बिकॉज nobody, I'm not going to set the paper for the GATE exam. Nobody is going to set the paper for the GATE exam. None of us is going to set the paper for the GATE exam. Okay? और IITs का हमेशा ही रहता है that वो उनको हमेशा अपना ईगो दिखाना है कि वो हमेशा ही देखते हैं कि नहीं, ये जो ट्रेनिंग दे रहे हैं, ये जो कोचिंग दे रहे हैं, इनको किसी तरह से मतलब इनकी बात काटनी है. तो वी आर रेडी, आपको भी रेडी रहना उसके लिए. ठीक है, तो ओके चलिए. सो लेट्स राइट दैट इफ देयर इज नो ब्लॉक डायग्राम, if there is no block, just write block, not diagram. If there is no block or summation point, ठीक है? If there is no block or summation point, what is the meaning of block? Any of these two. What is the meaning of summation point? These are the summation point. Is it necessary that in a block diagram there will be only two summation point? No, don't say that sir this is the only possible block diagram. ऐसा नहीं है. ये बस एक स्टैंडर्ड एग्जांपल दिया मैंने, स्टैंडर्ड नेगेटिव फीडबैक कंट्रोल सिस्टम. बहुत सारी चीजें हो सकती हैं. ठीक है, ओके. सो इफ देयर इज नो ब्लॉक डायग्राम और समेशन पॉइंट, द सिग्नल रिमेन एज इट इज. द सिग्नल रिमेन एज इट इज. What is the meaning of signal? What is the meaning of signal here? Let me tell you. Signal. Suppose this output is error. It is a signal. Controller output. Manipulated variable. Here also there will be something, right? Measured variable. These are signals Y. Signals YSP. Signal D. Signal. These are the signals. Block diagram. Summation point. And these are the signals. Fine. These are signal. Controller output. Error function, disturbance, y bar s, right? Measured variable, YSPS. These are the signals. Fine. So if there is no block or summation point, the signal remain as it is. Okay. Second point. If there is a summation point, if there is a summation point, if there is a summation point, then the input signals must be added algebraically. Then the input signals must be added algebraically, must be added algebraically to get the output signal. ठीक है, to get the output signal. Input signals must be added algebraically to get the output signal. Fine. What is the meaning of algebraic? Means you have to take care of these points. Plus, 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 minus. Right? I mean, suppose there is a summation point and from here I have the signal plus A, and here I have the signal minus B. So what will be the output? A minus, I mean just algebraic addition. So कहीं भी अगर बीच में summation point आ रहा है, it will be algebraic addition, including the sign. So summation means just you have to see how many signals are coming to that summation point. All those incoming signals should be added to give the output signal. These are some rules जो हमेशा follow होंगे. राइट, तो समेशन के बारे में बता दिया. इफ देयर इज नो ब्लॉक डायग्राम और समेशन वो भी बता दिया. व्हाट हैपेंस इफ देयर इज अ ब्लॉक डायग्राम? राइट, यहां कुछ और बताने के लिए नहीं है. ठीक है, मिटा दीजिए इसको. आई टोल्ड यू व्हाट इज फॉरवर्ड पाथ एंड व्हाट इज फीडबैक पाथ. अभी और बातें करेंगे क्लोज लूप ट्रांसफर फंक्शन, ओपन लूप ट्रांसफर फंक्शन, सबके बारे में. यहाँ ज्यादा डिस्कशन नहीं है, ये मैथमेटिक्स है तो ऐसा नहीं कि इसमें मैं कुछ डिस्कस नहीं कर रहा. इसमें ज्यादा डिस्कशन नहीं है. जहाँ डिस्कशन है हमने काफी करी है ना. जहाँ नहीं है चुपचाप वहां से आगे बढ़ लो, है ना. सिलेबस भी फिनिश करना है ना. सिलेबस हैज टू बी फिनिश्ड एंड एक्स्ट्रा नहीं पढ़ना है ना. When I am giving you this selective content, what is the advantage of studying here? The advantage is I have done something before you, है ना. मैंने आपसे पहले कुछ चीजें करी हैं, राइट. Preparation, failure, success, exams. So I'm going to save your time. That is the thing only. पढ़ना आप ही को है ना. मैं पढ़ाऊंगा नहीं, उंगली पकड़ के नहीं पढ़ाने वाला हूँ, बैठाने वाले नहीं कि बेटा बैठ जाओ, हाँ डेफिनेटली इफ यू आर फीलिंग समथिंग आई मीन नॉट फीलिंग वेल देन आप कॉल करते, क्योंकि आजकल क्या हो रहा है, आजकल बहुत कॉल्स आ रही है इसी चीज़ को लेकर राइट नाउ। आजकल थोड़ा सा ये चलता है, ये होता है एवरी ईयर, दिस इज नॉट अ न्यू काइंड ऑफ थिंग। प्लस ड्यू टू दिस आप ड्यू टू काइंड ऑफ ये जो आप घर में बंद हो ड्यू टू दिस लॉकडाउन क्वारंटीन, ये सारी चीज़ों की वजह से ये थोड़ी प्रॉब्लम ज़्यादा हो रही है। काइंड ऑफ फीलिंग दैट सर शायद मुझसे नहीं होगा, पढ़ा नहीं जा रहा, मन नहीं लग रहा है ना, मुझसे पता नहीं निकलेगा कि नहीं निकलेगा, डर लग रहा है, कॉन्फिडेंस नहीं आ रहा, ये चीज़ें आपके अंदर अभी आएंगे। दिस इज़ वेरी नॉर्मल इन द मंथ ऑफ अगस्त। द थिंग इज आपको इससे कोप अप करना है एंड देन बाहर फिर से निकल के आना, फिर से लग जाना। आएगा, ये हमेशा आएगा, मुझे भी आया, तुम्हें भी आया, राइट। वंस आई वॉज आई वॉज गोइंग विद वेरी गुड पेस। Actually, I always started the exam for at the very later point of time. बहुत ज़्यादा बाद में start करता था. Most of the time I started preparing in November or December. Most of the times I attempted GATE 4 times for myself. I was aiming for going to the PSU, and then later अभी तक मैं GATE दिए जा रहा हूँ. ठीक है, तो वो जो अभी GATE दे रहा हूँ, that is to maintain my dynamic nature. That time I used to aim to get double digit, single digit rank. मैंने हमेशा लेट तैयारी करी, always, but still I managed to do the things. दिसंबर में शुरू करता था, चीज़ें धीरे धीरे हो जाती थी। एक बार बहुत अच्छी तैयारी चल रही थी, बहुत पेस से जा रही थी चीज़ें। I remember that I think 27th और 28th somehow पता नहीं प्रिपरेशन अचानक बैठ गई और 3 दिन में कुछ नहीं पढ़ पाया था, 3 days, and those 3 days alone, क्योंकि मैंने वो 3 दिन, क्योंकि देखो मैंने बहुत शॉर्ट पीरियड में टाइम प्रिपरेशन करी थी, 2 और 2.5 months. I fixed those 3 days for revision of mathematics, particularly the formulas of numerical methods and all. पता नहीं किस रीजन से उस 3 दिन पढ़ाई नहीं हो पाई, and then everything was gone. राइट, सो ये सब आपके साथ नहीं होना चाहिए। देखो एक दिन खराब हुआ उसकी वजह से, और देखो दूसरी बात ये कि 3 दिन में ऐसा कुछ होता नहीं है, बट आई प्रिपेयर द थिंग्स इन अ वेरी शॉर्ट पीरियड ऑफ टाइम। दैट इज वाई वो 3 दिन, और वो भी 3 दिन बिल्कुल लास्ट के 3 दिन थे, तो वो मेरे लिए काफ़ी मेरे प्रिपरेशन में काफ़ी ज़्यादा बड़ा ब्रेक लगा गया, है ना। तो अगर मैं भी जून से करता, मार्च से प्रिपरेशन करता, होता है ना, ट्रफ्स क्रेस्ट्स आर देयर, बट आपको निकल के आना है, ठीक है। सो let's talk about the third way of solving this block diagram. ठीक है, third way, if there is a transfer function, so if there is a block diagram, sorry, if there is a block diagram, you know that each block diagram is having some transfer function. If there is a block diagram having it will be having some transfer function. If nothing, then it will be equal to 1, having transfer function equal to GS. Then we know that output, not that output, that, see, suppose if there is a block diagram having transfer function GS, and this is its output, and this is the input signal. Let's say that this is A and this is B. What is the formula of transfer function? This is B bar S, and this is A bar S. So GS is equal to output deviation variable का Laplace divided by input deviation variable का Laplace. So the output can be written as GS multiplied by A bar S, correct? GS multiplied by A bar S. Okay, so yeah, so this is how you have to deal with any block diagram, and whenever you see the block diagram, just multiply. So if there is a block diagram having transfer function this, I can continue with the I can continue from here. Multiply the transfer function, okay, with the input signal to get the output signal. Multiply the transfer function with the input signal to get the output signal. To get the output signal. ठीक है? So this is how you have to deal with these 3 components: summation, block and nothing. If there is nothing, आप जो सिग्नल जहां से लेके चले थे उतने का उतना ही रह जाएगा. One more thing, you can start solving the block diagram from any position you take, you can solve that. हाँ, it is possible, it may take some more steps. If you have not solved that block diagram earlier, it may take some more time if you are not starting from that optimum position. पर कहीं से भी start कर सकते हैं और block diagram solve हो जाएगा. Now, I am repeatedly saying there is no need of solving 100, 200 block diagrams. Just 10, 11, 20, 3-4 problems class में कर लेंगे. उसके बाद कुछ गेट की होंगी, ठीक है, गेट की भी कुछ कराऊंगा मैं क्लास में, है ना। बाकी प्रॉब्लम्स अगर एक आधी 4-5 ब्लॉक डायग्राम सॉल्व कर लेना, ऐसा ना हो, देखो वही क्या होता है ना, मैं आपको बता रहा हूँ कि आपके अंदर कॉन्फिडेंस नहीं होता अपनी प्रिपरेशन को लेके, आप जरा सा टेढ़ा क्वेश्चन देखते हो नहीं आता, आपको लगे यार कि आपको ही कुछ नहीं आता, सारी चीज वहीं भरी है ना। द ग्रास इज ऑलवेज ग्रीनर ऑन द अदर साइड, वो वेरी इंपॉर्टेंट, वेरी आई मीन कॉमन सेइंग है ना। आपको कभी लगता है कि यार मेरी प्रिपरेशन खराब है, सामने वाले की ठीक है, मैं इसका मतलब ये नहीं कह रहा कि अपने प्रिपरेशन को हल्के में ले चलो, करो, बट नेवर फील दिस कि यार अगर आपसे क्वेश्चन नहीं हुआ इसका मतलब आपकी प्रिपरेशन ठीक नहीं है। नेगेटिविटी नहीं आनी है। क्वेश्चन नहीं हुआ तो सबसे पहले एक चीज तो दिमाग में हमेशा रखो, इधर उधर से जो क्वेश्चन मिल रहा है एक्सेप्ट गेट, इवन आई एम सेइंग आई एम गिविंग यू क्वेश्चन, उस पर ब्लाइंडली नहीं करना कि नहीं यार ये क्वेश्चन नहीं हुआ मैं तो गया, ठीक है, ऐसा नहीं है। आई गिव यू क्वेश्चन समटाइम्स जस्ट टू पॉलिश योर कॉन्सेप्ट्स, ठीक है। And obviously in GATE exam also there will be situations wherein you will not be able to solve a problem. तो ये जो फेलियर की ना आदत डाल लो, मतलब फेलियर की ऐसी आदत डालो, मतलब इतने ढीठ बन जाओ कि नहीं हो रहा कोई बात नहीं, मैं लेकिन अपने काम में लगा रहूंगा मैं। योर एटीट्यूड शुड बी कि मैं लगा रहूंगा, क्वेश्चन सॉल्व नहीं हो रहा ना हो कोई बात नहीं, मैं लगा रहूंगा, वो क्वेश्चन आगे सॉल्व, वो देखो एक तो सेम क्वेश्चन उठ के आना नहीं। सेकेंडली आप कहीं भी किसी भी सोर्स से क्वेश्चन सॉल्व करते हो, अगर करते हो एक तो पहले करो मत इधर उधर से, और अगर करते हो देन प्लीज एक वो माइंडसेट मत बनाओ कि नहीं सर मुझे वहां फलाना जगह से मैं क्वेश्चन ले आया, मुझसे क्वेश्चन सॉल्व नहीं हुआ मतलब मुझे नहीं आता, ऐसा नहीं है। डिस्कस इट एंड प्रोबेबली एक बार चेक कर लो खुद से, यार कहीं ऐसा तो नहीं कि क्वेश्चन ही गलत हो, ऑप्शन गलत हो, सिलेबस में ना हो, क्योंकि बहुत दिक्कत होती है। लोग क्या करते हैं, परेशान करने के लिए स्टूडेंट्स को क्वेश्चन बना देते हैं बस, फिर ठीक है देख लेगा पता लग जाएगा इसको, फिर आके खुद ही पूछेगा सर इसका बताओ इसका बताओ। बच्चे बच्चों को देखता है कि हाँ भी ये क्वेश्चन मुझसे नहीं हो रहा, जरूर उन सर ने कुछ बहुत तगड़ा पढ़ा दिया होगा, कुछ ऐसा नहीं है। यही चीजें आती है पेपर में यही चीजें आती हैं। ओनली 4-5% सिलेबस हैव चेंज्ड। कई बच्चे अभी उस सिलेबस के पीछे भाग रहे हैं, ठीक है, भागना छोड़ दो, आ जाएगा समय पे मिल जाएगा यार, कुछ भी नहीं उसमें। ज्यादातर जो चीजें ऐड हुई हैं वो थ्योरी है, एंड आप देखोगे व्हेनेवर न्यू टॉपिक्स आर एडेड, न्यूमेरिकल्स उससे कम आते हैं, थ्योरेटिकल थोड़ी ज्यादा आते हैं, ठीक है, फिर भी न्यूमेरिकल्स भी कर लेंगे बट वो ज्यादातर थ्योरेटिकल क्वेश्चन है। उन 5% के पीछे मत भागो, जस्ट एम फॉर 95%, इट इज स्टिल द सेम। इवन जो 5% ऐड हुआ है, कई बार उसमें से कुछ चीजें मैं पहले भी पढ़ाता था, उसको खैर निकाल दिया था काफी टाइम से, कभी आया नहीं, ठीक है, तो वो कोई दिक्कत नहीं है। लेकिन ये नहीं समझ आया तो अरे नहीं सर मुझे मतलब कि कैटलिस्ट डीएक्टिवेशन नहीं पढ़ा है, अभी नहीं पढ़ा है, बाकी चीजें तो देख लो यार, है ना। कैटलिस्ट डीएक्टिवेशन कोई नई चीज नहीं है, वही वैसी रेट लॉ है, वैसी रेट एक्सप्रेशन बनेंगे, कोई बहुत टॉप चीज नहीं है। 2-4 टर्म्स अच्छे से आपको याद करनी पड़ेगी, न्यू टर्म्स आर देयर, न्यू टर्म्स विल बी इंट्रोड्यूस्ड। हार्डली इट विल टेक 14-15 आवर्स, अगर मैं पूरा मतलब जितना पढ़ाना है सब पढ़ा दूं, 14-15 आवर्स टू कवर ऑल दीज न्यू टॉपिक्स। कितना टाइम लगेगा यार, गेट के एक दिन पढ़ लोगे, कोई दिक्कत नहीं है ना, इसमें कोई ऐसा रटने वाली कोई मतलब बहुत ज्यादा ऐसी टॉप चीज नहीं है, फाइन, बट दीज थिंग्स आर बेसिक्स, ये आपको हमेशा आने चाहिए। ओके, so if there is no block or summation point, okay, I told you all the methods, right, how you have to deal with block diagram, summation law, and that's what I was saying, that आप सारे बैठ के ये मत कर जाना कि मैं 100-150 ब्लॉक डायग्राम में सॉल्व करूंगा, इसके आगे आने वाली चीज ज्यादा इंपॉर्टेंट है, right? So these were the rules. Of course I'm going to take some block diagram reduction problems first. If you are comfortable with reducing the block diagram, then only you will able to move a step ahead. We have seen that how many components are present in the block diagram. Now what is the objective? The objective is to reduce the block diagram in the form of a transfer function. देखो होता क्या है कंट्रोल सिस्टम में, जो इंडिविजुअल कंपोनेंट है, इंडिविजुअल कंपोनेंट का भी ट्रांसफर फंक्शन होता है, लाइक आई टोल्ड यू द ट्रांसफर फंक्शन ऑफ डिस्टर्बेंस इज जीडी, द ट्रांसफर फंक्शन ऑफ सेट पॉइंट इज एसपी जीएसपी, द ट्रांसफर फंक्शन ऑफ प्रोसेस इज जीपी, द ट्रांसफर फंक्शन ऑफ वॉल्व इज जीवी, द ट्रांसफर फंक्शन ऑफ मेजरिंग एलिमेंट इज जीएम, राइट? So each individual component always has some transfer function, and individual component के साथ साथ ये जो पूरा आपका block diagram बनाएंगे, entire block diagram also has some transfer function. So what is the objective here? That you have a little bit idea that how the feedback block diagram should look like. Now you should be able to reduce that block diagram in the form of a transfer function. So that is called block diagram reduction. Block diagram reduction. So reduction to what? Block diagram reduction to some transfer function. Please note कि ये जो transfer function बनेगा ये पूरे block का transfer function होगा, not the transfer function of individual components. Okay, so block diagram reduction to the transfer function. Fine. This is what we have to do because from here एक बार जब आपका पूरा कंट्रोल लूप का ट्रांसफर फंक्शन आ गया, देन ओनली यू कैन टॉक अबाउट स्टेबिलिटी, देन ओनली यू कैन टॉक अबाउट ऑफसेट, देन ओनली यू कैन टॉक अबाउट ऑर्डर ऑफ द ओवरऑल सिस्टम. फाइन. सो दैट वाज ब्लॉक डायग्राम रिडक्शन टू द ट्रांसफर फंक्शन. नाउ यू नो दैट आई टोल्ड यू द रूल्स. ओके, सो लेट मी मेक दिस block diagram again. Please note that in this block diagram, if I'm not making anything, if I'm not writing a particular transfer function, it means that transfer function is unity. ठीक है? Okay, see these are the individual transfer function. देखो इससे पहले जो मैंने आपको dynamics में पढ़ाया, in dynamics I have discussed the transfer function of individual components and their dynamics also. Fine. This is epsilon bar s. ये जो diagram है ये आपको रटा होना चाहिए, that you should always be able to make these control loop block diagrams. Okay, and you should also know that this is a negative feedback control block diagram. So GC, after GC it is the controller output, then it goes to the GF final control element, or GV also you can say, then it goes to GP, the process transfer function, right? And I told you that I'll be using a notation that this disturbance will be after this process, है ना, because gate में भी आप देखोगे यही नोटेशन यूज की जाती है. दिस इज डी बार एस एंड आई हैव वाई. दिस वाई इज मेजर्ड, यहां से नहीं करना है, वाई इज मेजर्ड एंड देन passes through a measuring element GMS and then goes to here. Fine, this was the diagram. Now the target is to make this transfer function for this entire loop. Now when you make the transfer function, I gave you some rules. What are the rules? That if there is no block diagram or summation point, keep the signal as it is. If there is summation point, add the signals. If there is a block, then output signal is equal to input signal into block transfer function. So you can start from any point. आप यहाँ से start कर सकते हैं, यहाँ से start कर सकते हैं. See, this is y. There is nothing in between. So what should be this? This is also y. This should also be y. Correct? भाई जब तक कुछ नहीं आएगा तब तक सिग्नल में कोई चेंज नहीं होगा. सो दिस इज वाई वाई वाई, एवरीथिंग इज वाई. एंड व्हाट इज दिस आउटपुट? ऑफ कोर्स दिस शुड बी वाई इनटू द ट्रांसफर फंक्शन, बिकॉज नाउ देयर इज अ ब्लॉक. ब्लॉक मींस आउटपुट इज कैलकुलेटेड एज इनपुट इनटू ट्रांसफर फंक्शन, सो दिस शुड बी वाई इनटू जीएमएस. ठीक है? नाउ दिस इज वाई इनटू जीएमएस. व्हाट इज दिस? वाईएसपीएस इनटू जीएसपीएस, है ना? वाईएसपीएस इनटू जीएसपीएस, so this should be YSP. I'm not writing S again and again, right? So I'm just dropping these S in the parenthesis. So YSP into GSP. At the summation point, these two signals must be added algebraically. So I'll write YSP into GSP and this minus Y into GM. Correct? That is the error. So if you ask me, sir, what is the value of this error? So this multiplied by minus this. So this is basically error. This error goes to the controller. So what is this output? Controller output. So if you ask me, sir, what is this? This is error, epsilon bar S. Okay. What is controller output? Controller output is equal to error into the GC transfer function. This is error, so it becomes YSP, GSP minus YGM and that multiplied by GC. Right, this becomes the controller output. Then it will be multiplied by GF to give this manipulated variable. Then this manipulated variable will be multiplied by GP and we will be present here. So what is this signal? Suppose आप इस signal को कुछ भी नाम दे सकते हो. Suppose आपने इसको A कह दिया. See, whenever you are reducing a block diagram, if you are giving name to a particular signal, this name has been created by you. ये आपने खुद से assume किया ना. So later in the final form, this A must be removed. It must be replaced or substituted, है ना? फाइनल फॉर्म में A नहीं दिखना चाहिए. तो what is A? If I ask you, sir, what is A? What do you think? A is equal to, so up to this we have controller output YSP GSP minus YGM, that multiplied by GC. GC gives you CO, and that multiplied by GF. I'm not writing S everywhere. This gives you manipulated variable multiplied by GP gives you A. Now that A must be added because there is a summation sign. And what is this signal? This is D bar into GD. So this should be, I'm not writing bar also, D bar into GD, and that must be equal to Y. ठीक है? This is how a block diagram is reduced. कहीं से भी शुरू कर लो, है ना? Of course, if you start reducing the block diagram from a particular point, it may be easier as compared to from other points. So that you are going to learn only after solving some block diagram problems. Fine. So this is how you have reduced this. So A is equal to this, and एक काम करते हैं, A को यहाँ से हटा देते हैं, because what was A? A was, this much was A. Fine. So I have replaced A. I am not using A in the final form, right? Now I told you that in physical system also there are two cases, two types of problems: the servo problems and the regulatory problem. ठीक है? So because these block diagrams are the representation of physical system only, so here also there will be servo system and regulatory system. So I hope you remember that in servo system or in servo problems, what is changing and what is not changing, right? And in regulatory problems, what is changing and what is not changing. Regulatory problems, what is changing and what is not changing. Okay? So what is servo? In servo problem, you know that set point changes, and if set point changes and disturbance won't change, what is d bar s? D bar s will be equal to 0. Servo में यही होता है, set point change होता है, disturbance change नहीं होता है, right? So d bar s is equal to 0. So this entire term dgd becomes equal to 0. What do we have? We have this YSP GSP is equal to Y into, I'm taking this term on the right hand side, 1 plus GM, GC, GF, GP. Correct? And from here in servo problem, which transfer function you are going to make? You'll be writing the transfer function. So space banate yahan pe. After this, I'll write regulatory. The transfer function will be Y by YSP. In fact, I should write this as Y bar S divided by YSP bar S is equal to GSP. If GSP is not there, then not a problem. In that case, it will be 1 divided by, there is YSP, GSP and DGD, right? So, yeah. So there should be YSP, GSP. Okay, this will also be multiplied. This will also be multiplied. YSP, GSP, GC, GF, GP. Sorry. So YSP, GSP on the left hand side, it will be GC, GF, GP. So correct kar lena, is equal to Y multiplied by 1 plus GM, GC, GF, GP. Correct. So according to this, Y by YSP should be GSP, GC, GF, GP divided by 1 plus GM, GC, GF, GP. This is the transfer function of the block. एक individual component का transfer function तो पहले से ही पता है ना. We have discussed separately about controllers. We know the controller are having transfer function GC is equal to KC, GC is equal to KC into 1 plus 1 by tau is. So those are the individual transfer functions. So, but what is the transfer function of this entire block? Now, the transfer function of the entire block should be divided into two types. One is servo problem and the regulatory problem. So this transfer function which you have found here, we have certain names for this. First of all, this one is called closed loop transfer function. सबसे पहली बात ये कि closed loop transfer function. Why? Because in this transfer function, the feedback loop is closed. Okay, so closed loop transfer function. But which type of closed loop transfer function? Servo problem. Here, what is changing? YSP. What is not changing? Disturbance is not changing. So we can also call it servo closed loop transfer function. I will write closed loop transfer function in short. This can also be called as set point closed loop CLTF, I will write in short for in the upcoming expressions. So this can also be called as set point closed loop transfer function because here servo problem is there. तो ये इस पूरे लूप का, पूरे क्लोज लूप का ट्रांसफर फंक्शन है in that case where disturbance is not changing. Now suppose you have regulatory problems. For regulatory problem, you know that regulatory problems, we know that for regulatory problems, we know that disturbance changes but set point won't change. So definitely I will write here that YSP bar S should be equal to 0. ये समझ आ रहा है ना? So in that case, this expression becomes, you can write this expression as this YSP becomes equal to 0. So we have DGD is equal to Y into, very simple to write this, 1 plus GM, GC, GF, GP, correct? So we have Y bar S, which is the output, divided by D bar S, which is the input. Here the input was change in set point, here the input is change in disturbance. So it is obviously equal to GD divided by 1 plus GM, GC, GF, GP. So this is another closed loop transfer function. Another closed loop transfer function. So this should also be called as CLTF, but which CLTF? This should be called as regulatory closed loop transfer function or disturbance closed loop transfer function. Disturbance closed loop transfer function. ठीक है, closed loop transfer function. I can also call it regulatory closed loop transfer function. So first of all, you must know that whenever you have a block diagram, in that block diagram, if you reduce it in the form of this equation, there can be two cases. One is servo problem, one is regulatory problem. It is possible that when you are solving a problem in gate, in that block diagram, there is no disturbance. Disturbance है ही नहीं उसमें, कोई दिक्कत नहीं. In that case, you will be only able to write this servo transfer function. So a block diagram can be written as a closed loop transfer function in the form of servo problem as well as in the form of regulatory problem. ठीक है, तो ये चीज ध्यान रखना है कि कैसे लिखना है. Now there comes a situation, you can see here that in these block diagrams, first of all, you can see that the numerators are different, but the denominator is same, and in that denominator you have this multiplication GM, GC, GF, GP. You can see that in both the cases, whether it is servo problem or it is regulatory problem, this GM, GC, GF, GP, it is exactly same. If you consider this, पहले लिख लो, ठीक है, आप फिर उसको दोबारा एक लूप बना लेना या फिर आप इसी में देख सकते हो ना, पहले आप नोट कर लो. I'm erasing this. If you consider that the feedback loop has been cut, suppose if you consider that the feedback loop has been cut, in that case, you can assume that from here I have cut the feedback loop. Now, using scissors, I cut this feedback loop. Correct? Now the feedback loop, इसका नाम दिया था ना feedback path. If the feedback path is not present, if the feedback path is not present, if the feedback path is not present, right, then in that case, if this is not present, then this point, right, or you can say if this is not present, कई बार GSP 1 होता है, in that case, this point error and the point Y, what is the relation between them? क्योंकि ये तो भाई है ही नहीं, ये तो है ही नहीं, है ना? In that case, what is the relation? That they are related as GM. You can see here that GM, GF, GP. I mean, you can see the relation here. If the feedback path is not present, in that case, this what is coming from here and what is entering here, they are related as GC, GF, GP and GM. What is this? ये जो ट्रांसफर फंक्शन बनेगा GC, GF, GP, GM, ये किसको रिलेट करेगा? क्या लग रहा है? देखो यहां से. Of course, what is the input here? देखो एक चीज सीधी बात है. When the blocks are connected in series, their transfer function are simply multiplied to get, see, what is this output by input is GC, what is this output by this input, GC into GF, this output by this input, GC into GF into GP. It's like non-interacting system. If the blocks are connected, आपको पता है non-interacting system का आपको example दिया था मैंने, when the tanks are connected in a non-interacting manner, you want to write the transfer function of fourth tank with respect to first tank. क्या करना है आपको, बस transfer function individual को multiply कर देना. The same thing I'm doing here, right? So in that case, yeah, GS, GP and GM. So this variable here and this variable here, they are related by this transfer function. Now this multiplication of GC, GF, GP, GM is referred to as open, when the loop is open loop transfer function, right? Transfer function. Correct? This is referred to as open loop transfer function, right? We will call it in short OLTF. So I can say that the closed loop transfer function, can be written as the product of forward path. What is forward path? This is the forward path. The product of forward path, pi stands for product, summation stands for sum, divided by 1 plus open loop transfer function. ऐसा चलेगा? Can I write like this? Now you'll say कि sir ऐसा क्या दोनों में होगा, servo problem and regulatory problem? See, when you're talking about regulatory problem, we are relating Y and D. In that case, the forward path only contains GD, right? When you are relating Y and YSP, the forward path contains GSP, GC, GF, GP. राइट तो फॉरवर्ड पाथ का मतलब हमेशा ये नहीं होता, इट डिपेंड्स विच वेरिएबल यू आर रिलेटिंग. while the open loop transfer function contains the product of all the transfer function present in the main loop. Please note that in the open loop transfer function there will be no GD, there will be no GSP, only the main loop which is this. यहां पे जितने ट्रांसफर फंक्शन के ब्लॉक्स हैं वो सारे आ जाएंगे ओपन लूप ट्रांसफर फंक्शन में, ठीक है. सो यू मस्ट नो दैट आई कैन राइट क्लोज लूप ट्रांसफर फंक्शन लाइक दिस, है ना. दिस इज अ सिंपल वे ऑफ रिमेंबरिंग द क्लोज लूप ट्रांसफर फंक्शन, और आपको बार बार ये ब्लॉक डायग्राम रिडक्शन करने की जरूरत नहीं है. नाउ प्लीज नोट अ पॉइंट, लिखवा देते हैं वहां पे. आई होप यू हैव नोटेड डाउन ऑल दीज थिंग्स. सपोज the feedback, this control system, this control loop is not a simple loop. What is the meaning of simple loop? This is a simple loop. If control system is not a simple loop, is not represented by a simple control system, तो आप ये shortcut use नहीं कर सकते. This shortcut is only valid, this thing is only valid for this kind of scenario, because I told you there are various control strategies and the block diagram can be very much complex also. In that case आपके पास एक ही option बचता है, that use the basic method, reduce the block diagram and then find the transfer function. Write down that CLTF is equal to pi of forward path divided by 1 plus OLTF is only valid, mark it, is only valid if, okay, is only valid if, yeah, the block diagram is simple. What is the meaning of simple? Simple तो बोल दिया. Simple is a very a kind of word which is not reflecting anything. Simple means, first of all, the block should be connected in non-interacting manner. Means change in this is affecting this, but change in this is not affecting this. अगर मान लो मैं यहां से एक और निकाल के ऐसे जोड़ दूं, then this is not non-interacting, this is interacting kind of thing. So blocks must be connected like this. अगर इसके अलावा, और सपोज इफ यू आर हैविंग एनी काइंड ऑफ सेकंड थॉट कि नहीं सर ये ब्लॉक डायग्राम जो है ये सिंपल नहीं है, इसमें जरूर कुछ लोचा है. If you are having any kind of second thought, then there is only one option. Reduce the block diagram by using some basic methods and then write down the transfer function. Is only valid for simple if the block diagram is simple. Okay. Otherwise, what you have to do? Otherwise, we will reduce. And I told you how to reduce the block diagram. We will reduce the block diagrams. We will reduce the block diagrams by using basic method. By using the basic method discussed and then find the closed loop transfer function. Basic method discussed and then find closed loop transfer function. एक चीज मैं आपको यहीं पे बता दूं कि देखो, in the next upcoming topics, you should be very, very careful that where I'm using closed loop transfer function and where I'm using open loop transfer function, and you should be careful about this in the gate also. Sometimes they give you closed loop, but for solving that problem open loop should be used. I mean, I'll tell you that for which problem which transfer function should be used. तो बस आपको ये याद रख लेना है, for solving a particular type of problem whether you have to use open loop transfer function or closed loop transfer function. Open loop आपको बताया क्या होता है, closed loop depends whether it is servo closed loop or regulatory closed loop. अगर ये शॉर्टकट लगाना है तो लगाओ, but not valid everywhere. This is not a universal rule for any block diagram. Please remember. Otherwise, you have to reduce the block diagram. ठीक है? So this was about the reduction of block diagram and the block diagrams. Okay. Now let us talk about a very important, conclusions which you can get from these closed loop transfer functions. Let's see. Because ultimately, after writing the closed loop transfer function, we have to check few things. What are those things? One is stability. तो stability के बारे में तो आगे बात होगी, but still, first point, write down. The order of the feedback control system is found by the denominator highest degree, found by the denominator highest degree in the closed loop transfer function. देखो, I told you that the proportional integral controller increases the order of the system. तो अब आप system का order पता कैसे करोगे? When you have controller, when you have the loop closed, in that case, write down the transfer function, closed loop transfer function. See the denominator. The highest power of S in the denominator will be called as the order of the overall system. ठीक है? Second thing, I also told you that if suppose in a particular case, if a transfer function is not mentioned, take it equal to 1, not a problem. Okay. So what else? The second thing is very, very important for us, and that is offset calculation. Offset calculation. बहुत ध्यान से सुनना, इस पे आपको बहुत न्यूमेरिकल्स मिलेंगे, और मैं इसलिए अभी आपको न्यूमेरिकल्स नहीं करा रहा, because ultimately see, unless you know how to reduce the block diagram, तब तक आपको ना ऑफसेट कैलकुलेशन का न्यूमेरिकल मैं दे सकता हूँ, ना आपको मैं ऑर्डर कैलकुलेशन का न्यूमेरिकल दे सकता हूँ, ना आपको मैं स्टेबिलिटी कैलकुलेशन का न्यूमेरिकल दे सकता हूँ. फर्स्ट ऑफ ऑल, ब्लॉक डायग्राम रिडक्शन शुड बी अंडरस्टूड, क्लोज लूप ओपन लूप ट्रांसफर फंक्शन शुड बी अंडरस्टूड. ओके, सो व्हाट इज ऑफसेट कैलकुलेशन? आई टोल्ड यू व्हाट इज ऑफसेट. ऑफसेट वाज स्टडी स्टेट एरर, है ना? ऑफसेट वाज steady state error. So offset is nothing but error. We know that what is the formula of error? Formula of error is set point minus measured variable. ठीक है? हाँ, R minus MV. Set point minus measured variable. But we are finding steady state error, means when the response has settled. After that, what is error? Means I have to see that what is set point after t tending to infinity. I mean, अगर set point भी continuous change हो रहा है तो वैसे देखो offset I'll tell you that point, and measured variable minus measured variable after t tending to infinity. तो मैं दोनों को सेम टाइम स्केल पे कंपेयर कर सकता हूँ. I can compare the set point, the difference between set point and the measured value only at the same particular span of time. ऐसा नहीं हो सकता कि मैं set point यहाँ पे ले रहा हूँ और इस टाइम पे ले रहा हूँ और जो measured value है वो मैं इस टाइम पे लेके फिर अब कंपेयर कर रहा हूँ. I have to take the difference at the same time. right? So that is why I'm taking a steady state error. So I'm writing a t tending to infinity पे जो difference आएगा, that is called offset. One more thing, that in PDC I told you that we always deal with deviation variable. So this is actually change in set point. ये कई बार books में नहीं लिखा होता है, but this is we have to deal with change in set point after. देखो ऑफसेट कोई नई चीज नहीं है ना, ये एरर ही है, तो एरर की तरह डील करना है. सेट चेंज इन सेट पॉइंट आफ्टर t टेंडिंग टू इंफिनिटी माइनस चेंज इन मेजर्ड वेरिएबल. थोड़ा सा इसको ऐसे भी समझना है, दिस इज चेंज नॉट द एब्सोल्यूट वैल्यू, चेंज इन मेजर्ड वेरिएबल, ओके, आफ्टर t टेंडिंग टू इंफिनिटी. फाइन. This is how you calculate offset. इतनी बातें clear होनी चाहिए. One more thing here. We always by default we calculate offset for step input. लिख लो. By default we calculate. आपके पास ऐसा नहीं होगा कि ramp input देके बोलेगा offset निकालो. Obviously ramp is unbounded, so the output will also be unbounded. Then how you can find the steady state error? Steady state आएगा ही नहीं कभी, है ना? So by default offset is calculated for step input, है ना? Offset is calculated for step input. Fine, let's talk about the methods now. ये कैसे calculate करना है? Because देखो offset calculation, you are going to find numerous examples, numerous questions on offset calculations in the previous years. Okay, so there should be no doubt here. Fine. So suppose let I told you the formula, right? Okay, so let us first write the formula in the form of some expression, and then I can talk about this. Offset calculation can be done. Offset calculation can be done. Calculation can be done for both servo and regulatory problems. For both servo and regulatory problems. ठीक है? Offset calculation can be done for both of these things. Servo के लिए भी offset निकलेगा, regulatory के लिए भी offset निकलेगा. So let us talk about servo problem first. Servo problem. But offset का formula क्या रहेगा? Formula remains same. ये जो formula है, यही formula रहेगा, ठीक है? Servo problems. Let us assume a step change of magnitude m in the set point, right? In the set point. अब ध्यान दो, यहां पे आपने किसको चेंज किया? सेट पॉइंट को. We have changed the set point, right? What is the formula of offset? Change in set point minus change in measured variable after t tending to infinity. Can I say that offset is equal to, say, we have introduced a step change of magnitude m in the set point. Even after t tending to infinity, the step change remains equal to m only. So offset is equal to, what is change in set point? m. Clear? कोई डाउट तो नहीं यहाँ पे ना? देखो मैं set point को change कर रहा हूँ. If I'm changing the set point, then and that is a step input. Step input is like this. So whatever be the time, the change in this set point will always be equal to m. So right? So that's why I'm writing this as m. ठीक है? देखो फॉर्मूला ये रहेगा, यहाँ फॉर्मूला नहीं रखना है. This is the formula for calculating offset. Minus change in measured variable after t tending to infinity. So actually I want to write here, what is change in measured variable? Capital Y is called change in measured variable. I want this value when t tends to infinity. This is the formula for offset. Correct? कुछ नहीं रटना है, ये रटना है बस. Can I write this as m minus yt at t tending to infinity can be written as by using final value theorem. S y bar s. कोई दिक्कत? S y bar s. What is S y bar s and S tending to 0? This is final value theorem. चलेगा? Now you'll ask, sir, okay, M is fine. S is S. What is y bar s? Okay. What is y bar s? M minus S into, this is S tending to 0. What is y bar s? Tell me, think about it. What is y bar s? we know that y bar s by x bar s is the transfer function, so y bar s should be equal to gs into x bar s. And what is x bar s? X bar s is the Laplace of the input, और आपने क्या input दिया? Step input of magnitude m. So can I say that this will be s into m by s, which is x bar s, multiplied by gs. Now what is gs? Here comes a point where most of the students make mistake. They take gs is equal to, I told you what is gs. gs should be the closed loop transfer function here, because you are calculating offset for this entire control system, है ना? सारे components सब काम कर रहे हैं. You have to take into, don't just write gs is equal to gp. Don't write gs is equal to gp, don't write gs is equal to gc, gv. Write the closed loop transfer function. But now the question arises, which closed loop transfer function? Servo or regulatory? क्या कर रहे हो? What is changing? It is a servo problem. Set point is changing. So what I should write here? I should write here servo closed loop transfer function. तो मैं यहाँ पे लिख दे रहा हूँ servo. I hope you understand what is servo closed loop transfer function. Offset आ गया. This is how you calculate offset. Where students make mistake, the students make mistake sometimes. They don't know कि here I have to take m or I have to take 0. See, simple formula. Change in set point after t tending to infinity. Set point is changing, yes. After that, the student make mistake here. Sometimes they use here regulatory transfer function gd by 1 plus gc gf gp gm. That is not correct. If it is a servo problem, I'm changing set point, so servo closed loop transfer function, and like this you will calculate offset. Let's talk about regulatory problem. Listen carefully. Regulatory problem. अगर regulatory problem है, in that case, let us assume a step change of magnitude m in the disturbance. Let us assume a step change of magnitude m. Step change of magnitude m in disturbance. ठीक है? In disturbance. Let us assume a step change of magnitude m in disturbance, correct? Then what? Okay, so can I say that, therefore, d bar s is equal to, just like here, it was ysp bar s is equal to m by s. Now we have d bar s is equal to m by s. Now please listen carefully here that how to find offset now. Offset formula remains same. What is offset formula? Change in set point after t tending to infinity. Now you tell me if it is a regulatory problem, what is change in set point? ध्यान से सुन लो. If it is a regulatory problem, what is change in set point? You'll say that, sir, if it is a regulatory problem, disturbance will change, set point won't change. So what is change in set point? If set point is not changing, what is change in set point? What is change in set point? 0. यहां गलती कर देते हैं, यहां m ले लेते हैं कि सर मैंने फॉर्मूला पढ़ा था. ये ऑफसेट का फॉर्मूला नहीं है, फॉर्मूला इज दिस. So if you are changing, the formula says change in set point after t tending to infinity, and you are dealing with a regulatory problem. What is change in set point? 0. Minus yt t tending to infinity. Again, you'll write 0 minus yt t tending to infinity. So I'll write this as 0 minus s y bar s and s tending to 0. What is y bar s? फिर से देखो 0 minus, ध्यान से सुनो. What is y bar s? Y bar s is equal to x bar. And what is x? X is the change in x means input. Input set point भी हो सकता है, disturbance भी हो सकता है ना. X means change in input. What is input here? Disturbance. So m by s, यहां 0 नहीं आएगा. This is input. This is not change in set point. This is the change in input. Or change in input is, because input is disturbance, so that is m by s multiplied by, this is a regulatory problem. So regulatory क्लोज लूप ट्रांसफर फंक्शन. यही बस एक गलती होती है जो स्टूडेंट्स कई बार कर लेते हैं. यहां 0 की जगह m लिख देंगे, यहां m की जगह 0. उनको क्लियर ही नहीं है कि फॉर्मूला कौन सा ऑफसेट का. दीज आर नॉट दी फॉर्मुलाज. फॉर्मूला सिंपल, क्योंकि ऑफसेट क्या कुछ अलग चीज थोड़ी. ऑफसेट इज नथिंग बट एरर एट स्टडी स्टेट, एंड एरर इज कैलकुलेटेड लाइक दिस, है ना. नाउ द क्वेश्चन इज कि सर क्या ऑफसेट नेगेटिव आ सकता है? यस, ऑफसेट कैन बी नेगेटिव. इन गेट एग्जाम सपोज इफ ऑफसेट इज कमिंग एज नेगेटिव, डोंट राइट द मैग्नीट्यूड, ओनली राइट इट विद द साइन. Offset can be negative because error can be negative. I told you error can be negative. Offset can be 0, error can be 0. Offset can be positive, error can be positive. Fine. This is how you calculate offset. Please be very, very careful whenever you solve an offset problem. Check करो, वो बताएगा नहीं कि regulatory है सर वो है. You have to read the problem, what they are changing. They may ask you that a change, what is the offset for a unit step change in the disturbance? Means this is a regulatory problem. What is the offset for step change of magnitude 10 in the set point? Means it is a servo problem. So you have to deal like this. And while doing this calculation also, while solving this limit, आपको थोड़ा सा सावधान रहना इसमें. This is how you calculate offset. This lecture was all about the theoretical discussion on the block diagrams. Questions लेने हैं, काफी टाइम से questions नहीं लिए, questions लेते हैं. But please note that now we will be taking various block diagrams. We will be solving them, calculate offset, calculate order, right? If it has changed, if it is same as before, that is also possible. So I'm going to take some closed loop systems now, and we are going to find all these things which we have discussed here.